So I'm just basically taking these bits off because, oh dear. I'm trying to upgrade this thing and it's just, yeah. I don't know, I'll move my microphone over here. Right, I don't know if that's any better, but it'll have to do for now. I just don't feel like doing it, to be honest, but I'm not feeling up to doing anything right now. But I've kind of got to push myself, cause, yeah. I want to get this thing upgraded with my new parts. I lost my spanner. Oh, there it is. So yeah, I think I'm going to dismantle it from this end this time because I went and put some glue on the other end to hold the bearing in place because it kept slipping and sliding and yeah, so anyway, I'm just going to, besides I want to sort these spaces out anyway, so I'm going to dismantle it from this end. Right, so I'm just, I want to take the brackets off because I've got some new brackets, some new grey 3D slotted brackets. It should be better for adjustment. We'll see. Unless I've screwed up somewhere and miscalculated something and I have to go back and 3D print something, I just don't know yet. We'll find out. I'm trying to get these washers off. Right. Oh, actually my brackets are going to be a bit wiggly to get off. Let's see if I can get to these little spaces. I want these. Come here. Right, can I get this off? Yeah, it's coming. Right, I need to put some support under this. Otherwise it's going to go plonk. Actually, the first thing I need to do is take my mechanism out, so I've just backed it off a little bit, so. Right, that'll give me some room to loosen these. I've got to yeah, I can push my spacers up now. I should be able to push that rotor along a little bit. Come on, there we go. Right, push the other rotor back as well, because I want some clearance. I just want some room. There we go. Right, I've got the rotors out of the way. I am so glad I made these little interface couplers. Makes life so much easier. Right, so I've got them apart now to loosen these nuts. Oh, I don't need to do that one, just this one. Get the device out because I've got to upgrade it. I don't need to take the whole thing apart, do I? No. Thank God for that. Oh yes I do, because I've got to get these frigging brackets off. I didn't want to be doing all this, but yeah. Oh well. That's life, I suppose. Well, I'll see first of all if I can actually do the upgrade without changing my brackets, but I think I've got to change my brackets, I think, because of this. These things will catch on the rotors when I put the wider. Let's see what I'm doing. When I put the wider, I've got some, I've got to put another concentric in the middle as well. Because it's a slight change in the design. Well, not the design specifically, but in the configuration, you know, the way it's set up. So yeah, I've got to put these new ones on. Right, the new grey ones. I'm going to replace the red ones with the grey ones, and I'm going to be putting my my new concentric assembly in. 4 of those are going to go in. I suppose I could do it without the middle one for now, just to compare it. Yeah, why not? I don't know. Yeah, I suppose I could do that. Then I won't have to change the brackets yet. That might be the way to go about it, actually. We'll see. So, can you see what I'm doing? Not really. Let's see if we move the camera a little bit. Can you see now? Well, if I move it this way a bit, we can see what I'm doing. Oops, pushing everything back together again. Oops, everything's going on the floor. I haven't got much room on this frigging table, I'll tell you. Okay, so, do I really want to change these brackets though. Anyway, let's just see. Yeah, because I want to replace these brackets because they stick out a bit too much, and I can't unstick them now because I stuck them together with acetone. I'm not sure if I can actually free them up to dismantle these little head pieces, because I made a new piece, you see, these things, I made these little U-shaped brackets that actually go over the top. So when this is on, these clamps basically clamp over the top like this on the inside, right? They go in there like that, sort of. Oh yeah, I remember now, I've got to trim a piece off here, haven't I? So they go over the top and they clamp on the inside so I don't get them in the way of the rotors. Yeah, I've got to trim a piece off these as well, because they're catching on the inside. Yeah, I've updated it in the SketchUp file, but I printed these before I realised. Oh, actually, I did print some more. They're still on the print bed. Just a minute. Let's see. There we go. I forgot about the ones I've printed on the print bed. Right, we've got some more pegs, which I'm cleaning up. And we've got some ones where I trimmed the back off so that it's a flat edge there. I'm cleaning up. Yeah. So I'm just gonna. Oh my God! What have we got on the floor here? Where's that drill gone? Wrong size. 6mm. Clear the holes out. Actually, I need 3mm as well. Not this print didn't come out very well. It'll do the job, that's all it matters. Yeah, it wasn't perfectly level on the bed, that's why I got a bit of shaping at the base and yeah, I decided to change the brackets because the original design, the brackets were in the way of the rotors and they were catching on the rotors a bit. And I didn't want to extend the laminations out because when you do that, you lose closer coupling, so I had to make these brackets that basically go on the inside of the device and hook over like an arm reaching over somebody's shoulder basically, and so they kind of look weird but they should work. And the bracing brackets, oh come on. It stops everything going wonky. Right, I've got my two brackets cleaned up, those two, in case I need them. But I've also, these have got holes in, and I can use pegs to go through the holes if I want. Whereas the other ones I did, I've got pins on one of them, one end. So I've got an option there of which ones to use. And, God, look at these pegs. Right state. I hate this. This silver filament is absolutely horrible. It's not like the pink stuff. The pink stuff was coming out great, and they've sold out of it, and I'm not surprised they've sold out of it because I bet everybody was buying that, because this grey stuff is absolutely shite. It really is. It's stringy. I tried adjusting my printer settings. I set it to pull the print filament back in between hops between objects. I even dropped the temperature a bit and it's made no difference whatsoever. It's just as bad. If anything, it's worse. Dropping the temperature has made it worse. I'm not going to go any higher than 260, and I was at 259 before. I'm not going to go any higher than that. It shouldn't need to be. It's just the quality of this plastic is just terrible. It's very gassy. I noticed that when it was printing, the printer head kept spitting all the time, kept going all the time when it was printing. So it's the gas that's causing holes in my prints, and there's nothing you can do about it. It's just in the settings. There's absolutely nothing you can do about it. It's just the plastic is shite. It's full of gas. It's gassing off as it's printing. That's what the problem is. So what I've got is these little holes in the print, and I've got stringy bits because it's going in between the hops and it's causing stringy bits, and there's nothing you can do about that. So if you look at this peg, it looks, I don't know if you can see that, but it just looks rough. It's not very good. Anyway, I'll have to acetone treat these pegs to strengthen them, but I mean, look at state of that. That's before I trimmed the shit off it. And I can't get rid of it. I've tried adjusting the settings. I've made the filament pull back 5mm before it moves to the next object to print, and it has made no difference. Absolutely nothing. No difference at all. If anything, it's made it worse. I've got more holes in the object than I had before, so. And when it's going and splitting while it's printing, you know there's something wrong with the filament, the actual plastic. They must have put something in it. They must have recycled some plastic and added some chemical or something to it to make it subtle or something. And it's the chemical that they've added that's just completely ruined the plastic. It's Chinese stuff, so I'm not surprised. The Chinese will try and make money out of anything. I mean, they get our old electronics and they recycle that. They send fake chips, copper chips and things like that. So. I've got 3 pins. And the frigging head just fell off on this pin. Frigging head just came off. What a load of junk. I've got to stick it back on with acetone now. Come on. It's blocked. It wants to stick to my finger. There's a big air gap in it. That's why it came off. Hang on. I don't think I'm going to be using these pins today. The hole's blocked, so where's my wire gone? I'll use my wire to unblock the end of this. Come out. Yeah, there we go. Right. So I'm sticking this pin that I printed back together with some ABS slurry and hope for the best. I'm hoping I don't need all 4 because this one's not going to be usable until it's dried, which is going to be like 4 hours or maybe more. Depends how much I put on there. Actually, I'll tell you what, I'm going to stick the other end on there because that end is terrible. Right, that's better. So, I'll just stick that over on the netbook and let it dry. This print is disgusting. This print material is disgusting. The worst plastic I had so far. It was alright doing the larger jobs, you know, this big thing. It was just on them little pins. Yeah, and I have to bump the temperature back up as well. Right, what's the next step? Let me just think. I've got 3 pins, not 4. Probably only need 2 anyway. Oh, yeah, they want some acetone on them, otherwise they'll probably break as soon as I put them in. God, this thing keeps blocking up on me. The acetone soaks into the fibres and bonds them together a bit stronger. So just do that pin. It's stuck to my bloody finger now. I don't want too much on it. Get off my finger, huh? Yeah, if I put too much on, they go like rubber and they kind of look like, they just go rubbery and dildo. Yeah, I don't want them like that. Horrible. Come on, get off my finger. Right. Horrible. Got the stuff on my fingers now. Okay, so let me think. Well, what do I do now? I can take the washers off. Because we're going to be a little bit wider. Right, I'll take my brackets off. Oh my god, look at these brackets. They're really warped. Look at that. Oh my god. Really warped, really bad. I can soon sort that out. Right, take the brackets off. The way to sort that out when they've warped like that is to get the frigging lighter on them and soften them. I need to, where's my lighter gone? There you are. Right, acetone's over there, but it's evaporating anyway, so just warm this up. Straighten it out. I tried to bend this while it was cold and it snapped on me. Not this one, another one. Right, that's gotten soft now, I can straighten it out. Stick it on a flat surface. I've actually got longer ones for the upgrade, which are over here, and they're slightly longer. I don't know if they're going to be long enough actually. Right, so the other one, really bent. I have to really straighten this one out because it's really, really bent. It's not warming up yet. God, my light's gonna melt. Okay, it's straightening now. Put it on a flat table. lighter was going to melt. I had this on once so long that the plastic holds the glint thing in place, melted, and the thing flew out and it went across the room, and that was the end of that. So I was cooling it down. Okay, the one that was bent really bad, it's now straight-ish. Oops. I think I've got some more of these somewhere. Let's have a look. I've got different sizes. Where's the other ones gone? I might want them longer. Oh, those are shorter. Yeah, those are shorter than others. I ought to make them adjustable, really. Yeah, well, these other ones, they're actually a little bit longer. Just 2 millimeters longer, but actually I probably need the longer ones, to be honest with you. Yes, I think I will. Let's just check that. Yeah, I'm definitely going to need the longer ones. So the ones that I just straightened out before, I'll put them aside because they're actually going to be a little bit short. So now I need to separate these like that. Ooh, I've got wires connected. I can't remember which way I twisted these wires on now. I twisted them clockwise, so anti-clockwise is the way, I think. Actually, do I need to untwist them? Yeah, I do. Because I don't like fighting about things dangling about. Come up, pan. Right, got one apart. Right, I've got them set now. Now I can work on each half. Take the... Oh, that's twisted onto that. Never mind, I've just taken all these frigging coils out. Ah! Yeah. These wires are connected as well. I forgot about that. Yeah. I need to get this frigging thing out of here. I need to prise that apart. This isn't working. This is difficult to hold. Got to prise this apart and wedge and lift that thing up at the same time. Come out. Hang on, gravity. Oh, gravity didn't work either, because The other end just fell off. Right. Just get this frigging thing out of here. Got ya. Right. That's one out. Get this other one out as well. Run. Got ya. Right. Half of it out. Now, this is the one with the fixed laminations. It doesn't turn. They don't rotate. It's fixed. Changing it for one's left-handed, one's right-handed. Yeah, I'm changing that end for this one. Right, so I'll put that one aside. And where's the other thing in the jig? Right, I've got to push this out of here. Oh, it's not so bad, this one. Got ya. Right, that's out. And that's got to replace that one. Check that out. And that one out. And that on there. It's straight. Right, that on there like that. Then the coil, which is still attached to that other coil. Oh, yes, the coil. I need to disconnect that because it's driving me to the wall. Come on. Got you off, that's better. Put this coil on. Actually, taking power from this particular coil from the end concentric is going to create a lot of lens drag, opposite equal reaction, blah blah blah, because it's going to be in the magnetic trap area, but it's going to be still interesting to actually monitor what's going on in the trap, and this coil will allow me to do that. It will basically monitor the flux that's being flipped across these laminations that are in there. So it will give me a good indication of what's going on in the trap. So I decided to keep the coil in there. The other magnetic gets right out. Ouch! God, that snapped my finger then. I want it on the other side. I want it on the other side, but I've got to make sure that the magnets are lined up with each other. So switch that around like that. Keep it lined up. actually fits. Yeah, it's the first time I put this together actually with the new laminations in there, so I wasn't sure if it was going to fit alright. It should do, because the hole size in the middle is the same as the other ones. These, yeah. Except with pink. Right, so that's that one. And that basically goes in here. And I need to get the wires facing inwards, otherwise I'll have a trouble getting to them. Let's see, that goes on the inside. See, that goes clockwise, so that's the right way. So we want this on. I'll put the wires sort of facing out. Now there's one difference with this, there's no hole in the middle because of the laminations. Because there's no frigging hole, I can't use these, because they're too long now. They won't go in, there's no hole. So what I did was, I 3D printed some itsy tiny ones, and they've been drying up for the last few days. So I've got some tinier versions there. These are going to substitute the long ones. But it still hold it, because as long as these little fingers that come out on the side hold these at the top, they will actually grab onto the secondary coil which goes next, which is this one. So the secondary coil will do the anchoring now. So this little one will go in there like that. Oh, I've got the wrong. This is not the secondary coil. Come on. Where's the secondary coil? There's the secondary coil. Right, the secondary coil goes on like that. And then this thing goes in like that. And then this will hook into the other secondary coil, and the other secondary coil will be anchored by the center pin, plus it will be inside the fingers which hold it, so everything will stay linked together. Right, so this thing wants to be dealt with now. So I'm going to take that off there. Take that off there. Take my pair cores out. Put my other lamination assembly in there. Oh, just a thought. There is a difference between which way around these go in. Never mind. Oh, what I should do is check this one in a minute. Let me just double check this one in a minute before I get too far ahead of myself. There is a slight difference between them, so let's just pull this out a minute. The difference is that the laminations are a little bit more. There's a little bit more iron on one side than the other, so let's just check. Which is which. Right, the thin iron on the outside, which is right, because we want more coupling on the secondary coil. Get on. Right, so actually that's so loose I can rotate. Right, back in again. You go. I need to mark these. Pen, where have you gone? I'm just going to mark it with a T. That works. Ah! Damn it! Does it still rotate? Yeah, it does. It works. Right, I'm going to set them up. This wire's going to snap off at the rate I'm going to keep knocking the wires. Secondary coil. Right, let's mark these others off when I'm at it so I know which is which. Because once you put the magnets on you can't really see. So that's a T. T as in thin end, because the steel is a bit narrower, a bit shorter on this end than it is on that end. So. Right, so that's marked with a T, let's mark the others. That's a T. Oh, I've actually put N on there. Oh well. I'll just put a T there. Thin end. And the other one. Oh, this one's tight. Come out. Oh. Oh. Which one's thin on this one? This one. T. Sorry, this is boring, I know. Yes, but yes, it is when you're not actually seeing any progress, but we are getting there, we are slowly getting it assembled. Okay, right. Get these, put the thin end in there. God, this one's tight. Where's my file? Diamond files, I love you. You are so efficient. Right, we'll go in now. I wonder if I can push that in on first. Oh yeah. So if I put that in on first, push it down, that'll work. It is tight on the other end. I just hope my ring isn't going to fly apart and the magnets go everywhere, because that could happen. Right, I've got that on. Coil. Oh, this Captain tape's coming off. I want the wires right in the middle of the magnets, so I don't want to short enough on the magnets. Right, let's start there. Put the magnets on the other end. Oh yeah, they line up alright. So they don't want to go where they don't belong. So let's see. Just a minute. Put that one in there. Yeah, I think I'm going to put the middle concentric arrangement in there later, I think, because I just want to see what the difference is without iron. Okay, now secondary coil. Spacer. Right, I've got one side done. Done sort of ish, because I've still got the middle concentric I want to put in, but I think what I'll do is I'll just try it. Now I've got to change these out, the other end, and I bet the wires are connected on here as well. Right, part that one out. I'll move this over here so I can work in this space, because I think this is where the camera's pointing. I'll pop this one out. Oh, this one looks like it's going to come out easier than the other ones. Yeah. Come out. This one's stiff. I'm so glad I put that hole there. Right, got you. Okay, so this one gets replaced with this one, which is adjustable. And I've got it. That's the right way around, yeah? Yeah, that's the right way around. Right, so I'll put that one aside. And we are adjustable. Both ends. I've just signed it in the middle-ish, where I think the middle is, which is when they're lined up. Right. I've got to swap these out now, so put that down there. Pop these cores out. God, got a lot of ferrite cores lying around my desk all of a sudden. I'll put them all back in their bags, I think. Look at all these ferrite cores. Mind you, 2 of them were already on my table, so technically I've only removed 4. Yeah, I've got to put them away soon, because if I drop pliers or anything on them, they'll smash. They're just like glass. Actually, I said 4. Make that 5. I'm just taking another one out. So by the time I finished, I will have removed 6 or 7. Oh, shucks. This one, oh, I think this is the one I glued together before. It's just broken on. Look at that. It's broken on me. Was it glued? I think it was glued before. Either that or I've broken it now. Anyway, I'm going to have to super glue this thing back together because otherwise, if I don't, it will get lost and I'll never flipping ferrite cores. So I'm just going to super glue this bugger back together while I'm at it. I think I used acetone and something before to stick one of them together. I don't know which one it was, but come on. Doesn't matter that it's broken as long as the super glue sticks it back together again. Right. Right, I've just super glued it, it'll be alright. Doesn't affect it too much. I think, yeah, one of them was broken, I seem to remember, and it wasn't stuck properly. I think I used something else to stick it together, but this is why they need to be put back in their bags and in a safe place, because they're just so brittle. Right, so got them rings clear. I need to do this one as well. My captain tape's coming off. I can't get this one out. Come on, there we go. Coming out. Oh yeah. Right. Two more of these to do. Oh, there's that one to take off as well. Right. Thin end. Get on. It's just getting them started. Okay. I'm just shampooing the edge of the plastic. It will help it go on. What do you call it? Breaking the edge, as they say. I should go on easier now. Nearly. Come on. Schubert is typing. Come on, you can go on there. Actually, I'll put it on the table. flat surface. Right, it's so pretty tight. I'll tell you what I'm going to do. I'm going to push that one down. It must be that edge. It's got a sharp edge around there. That's what it is. Put the coil on this end. It should work that way. Oh yeah, I've broken the edge on this one. So if I put it on this way around, you should be alright. Got ya. Talk about a lot of effort. Right, get my other ring on. Get that lined up on this end. Transpose it over and we should be right. Okay, let's see. There, I've got you at last. Okay, that's on. Thin end. That's why I wrote the T on there. So good I did that. Yeah, right, so I'll get this one lined up with that one. Put my secondary on. Oh, the spacer's in the other side, so I don't have to worry about the spacer because it'll connect to that one. Put it together. Right. And this other one. Something just moved. Damn it! One of the laminations is moved. I need a metal flat surface now. Where's my steel ruler gone? I can never find it when I want it. My steel lamination's just moved. I have to push it down and then I'm going to have to super glue the damn thing back in. Why is it moving? Oh, I've got a plastic thing there. That's it. Right. Get it flat. More super glue. Stick it in place because the frigging thing moved. I think I'll put it in the side here. Oh, I'm going to have to be careful because if I put this in there and it gets super glue on the inside of the magnet holder, I'll never get that onto now if I want. Right, that's definitely going to be stuck permanently in there. Wipe the excess super glue off. Because I don't want to stick this permanently into the magnet holder. Damn it, I'm going to have to wait a minute or two while this dries because it's I can't stick it in there while it's wet with super glue because I'll never get it out. So I'm going to wait a minute or two. Still wet. It's sticking in my fingers. Where's my acetone gone now? There you are. Ah! Got super on my fingers. Right. This should be set by now. Well, I'm going to have to risk it and hope that the super glue doesn't stick to these magnets. Mind you, a little bit of acetone would break that seal, but it's not going to be too bad. So, that one's really tight actually. Let's put my file. Right, that's one coil. Oh, this flipping Captain tape, it's coming off on everything. Pronounced Capton tape, it's spelled with a K. I can't get it on. Hang on. Ah. Yay, at last. Push that through a bit. It's still coming off. It's flipping Captain tape. I'm just going to trim this loose bit off because it's not sticking. One trick is to super glue the Captain tape the end of it. That's better. These actually go in easy and come out a lot easier than the ones. I think it's because I printed them with 100 divisions instead of whatever they were before, so they make a better circle. So they do fit solid better. And they're easy to get out. Right, so that's that. So I bring them together with my spacers and my plastic. And oops, damn it. Right, I want my clamps on. Where's my clamps? These are the ones. I think these clamps might be too big though. I don't know yet. Find out. If they are, I'll have to put the smaller ones on. It should fit. I think it's going to be I think they're going to be very snug. There, yes, perfect. Yeah, just the right size actually. So, thinking about it, I couldn't have put my middle spacers on yet anyway because these clamps aren't big enough. So what I'm going to have to do is print clamps that are basically 8mm longer. There we go. The clamps hold everything together so that instead of me having to physically hold them together like this, the clamps do that for me. Yeah, we've got a bit more sliding around though on these coils, which I'm not happy about. That's because I think it's because these spaces inside are a bit narrower. I might have to wrap some tape around them. Yeah, I think I'll do that actually. Take the clamps back off again. Come on. So yeah, there's a lot of slop on these. These are very sloppy, so what I need to do, oh god, these do fall out easy, blooming heck, so flipping easy, they just literally. Hang on. That one's not in right, I don't think. Oh, this one's warped. Yeah, this one's warped a bit. It's alright, once it's clamped, it'll be fine. Yeah, so what I'm going to have to do, because these frigging things, I'm going to have a bit narrow, I think. Another thing I could do, instead of using these shorter ones, which are actually narrower, I could simply cut some of these bigger ones down. Oh, hang on a minute, just a minute. I have got some of those that I never used. I need to find them. There we go. Right, these might actually work. I've got these pink ones which are the same width as the other ones, but are they the right length? Ooh, they're a little bit longer. I might have to chop these down. Let's see if they'll fit first. You know what, I don't think they are going to fit. I think they're going to be too long. Yeah. So what I'm going to have to do is chop these two down to the same length as these grey ones, and then I'll be good. I won't have to start bodging it with tape. Right, so let's see. Cutting them down is easy. Just use my chisel. So I'll stick that on there like that. Put all that in. that one. Yeah, these, I never use these other ones, so it'll be a good thing, because I redrew these, I must have got the diameter wrong. And these are a lot chunkier. So what I need to do is, actually I'm going to start it off with my hacksaw. I'll start it off with my hacksaw and then I'll use my chisel and just split them. Because I'm cutting along the filament lines anyway, so. Right, I've just started that one. It cuts pretty easy. Once I get it weakened, it'll basically just split. I don't damage the table, so get my chisel. Pliers and oh, I just realised it's pretty late, early in the morning. I'm going to wake my neighbours up. I'm going to find something that's not as noisy as my pliers. How's the paperweight? Paperweight wrapped in a towel. Paperweight wrapped in a towel should do the trick. Oh shit. God, this is tough. I tell you, this is what acetone does to your plastic. It makes it solid. It's so frigging solid, I can't even split the damn thing. Let's try the other one first. If this had come straight off the printer, that would have split by now. Oh my god, it's so hard. I'm going to have to do this on the floor actually, because I've just realised the microphone's near the thing. I'm going to do this on the floor because it's going to deafen you. Oh, I've got a better idea. I have a better idea. All I have to do is get my pliers, and because I put a little cut in there, it should split. Oh, actually not my pliers. My steel cutters, this should work. Trying to get in the hole in the crack. Bloody hell, this is so strong. I can't even get a grip on it. I tell you, I 3D printed this and I treated it with acetone, and it's been sitting on over there like for about a month, and it's rock solid, this plastic, it really is. Let me think. I'm just going to go back to the hacksaw. I'm just going to cut a bit further through, and if I cut further through then it will weaken it more. Keeps sliding around on me. I've got no grip. Stop sliding. Where's my towel? Paperweight wasn't with good. I tell you, this is what we want when we 3D print something. We want something that won't. I might as well just cut the damn thing off all the way through. There. That is what you call a solid 3D print job. There's the bit I cut off. That is one solid piece of plastic, that is. It's as good as it's as good as injection molded plastic when it's been acetoned, I tell you. I'm just trimming the rough bit off here. There's two ways of doing it. One is to put it in an acetone gas environment in a sealed plastic container that's preferably made out of nylon because the container would melt otherwise. Or just to squirt acetone all over it and with the syringe, which is what I usually do, and then stick it in a plastic container, let it dry nice and slowly, otherwise you can get warpage and it starts to curl on you and everything. Right, that's one piece that's done, and I tell you, I can't even see the fibres, it looks solid. I don't know if you can see that. Well, yeah. Right, the other one, I just need to finish hacksawing that one as well, because trying to split it with the chisel just wasn't cutting it, literally. I could have done it if I'd hit it a lot harder, but then, as I say, it is pretty late or early, depending on your point of view, because it's like 5 a.m. where I am. Got you. Okay, I have my new center I have to trim a bit off because my hacksaw cutting wasn't perfectly straight, so right, that's better. That should be perfect now. Let's compare it. Yeah, we're good. That is still a bit cockeyed, is that one? I don't want things looking limp and leaning. Right, this should work now, so I'll stick these in here now. Yeah, there's less wobble. Definitely less wobble. And bring them together. It's difficult because this one's warped. It'll be like once it's clamped up. Ah, come on. Right, that's better. Hold it together tight. My coils have drifted. I want the wires together so it's easy to join them together. So this coil should be up here. That coil. I'm trying to get the wires lined up so this is easy. They're all pretty much in the same line alignment. Up. Oh, get that one on there. This other coil at the bottom is in the wrong place. Alright. Come here. Right. Wires. Turn this. I want to clamp it. I can't turn it as easy, you see, so I'm having to turn this freaking coils around. Right. God, this other one's been like pain. Just a minute. Right. Put the damn thing together now. Right, clamps. Oh yeah, that's better. Oh, there's a lot less wobble on that now. There we go. 2 clamps. Actually, I wonder if the smaller clamps would fit as well, because there is a bit of slop on these. I'm just going to see if these smaller clamps will reach. I can put, there's no harm in having extra clamps on there, because there's a bit of warpage I've got to deal with, you see, with the ABS, one of the, yes, I think I can get them off. Actually, no, it's a bit of a stretch. It's literally a stretch. These things are just stretching too much. Yeah, I'm just going to stick with these. I think they're going to be alright. Because I knew that the steel laminations were fractionally longer than the ferrites. The 2 ferrites on each end, that's 16 millimeters each end. Well, the new ones I put in are a little bit wider than that, so. Oh, that's better. Alright, so we're going to try this. I'm going to connect this back up again, hook this all back up. And before I actually change these clamps. Oh no, I can't, because I put square holes in here for square pegs, haven't I? What should I do now? My holes on here, the square holes, and these are round pegs. You can't put a round peg in a square hole unless it's smaller. Oh, damn it! So does that mean I've still got to change my freaking brackets? Oh, actually, I just realised something. Silly me. These pins that I printed out, they're also round. They're not square. Oh, I printed the wrong pegs out, haven't I? Hang on a minute, have I got any square pegs? Yes, I have. But I've still got to take the brackets off. Oh, I tell you what, to hell with it. I'm just going to drill these friggin' holes out so I can put the round hole pegs in for now, because I'm really not in a mood right now to... I'm not in the mood right now to start batting about with square pegs and round holes. I'm just going to drill the square holes out, because I'm not worried about... It's only a test anyway. I just want to get the round pegs in there. I could still use the square peg later on anyway, because I've made these other brackets anyway. So. There's always a hiccup somewhere. So, I went to all that effort of making square holes, and now I'm drilling the friggin' things out again. The idea was that the square holes would lock and stop twisting motions. But yeah, thinking about it, actually it's not that practical, because there's still a certain amount of slop in the... Because of the pegs themselves, they actually shrink a bit when you acetone them, and so I don't think the square hole was a good idea anyway. But still, if you're using an aluminium square nut thing with a sleeve on it, whatever, it would probably be good. But yeah, I just will these fit in that hole? No, not yet. Oh no, I've got a hell of a lot of bloody drilling. I'm having to do this by hand as well. It's cutting my fingers up. In there. Yeah, it's gonna fit. But yeah, it's gonna fit. I've got another 6 holes to go. That's what you get for trying to change something, and then you forget your pegs round and not square. And can I hook this up to my electric drill? put my big electric drill away, and I don't want to start getting that thing out right now. Oh, actually, what I could do, oh yeah, if I stick my 6mm drill into this rotor adapter, I've got a bigger grip on it. I'll probably do this. Because it's 6mm wide, it's the same as the spindle diameter, so that'll work. That'll work. I won't cut my fingers up now. I think we'll start with a small one. And I've got to. There's another reason why I don't really want to use electric drill. It's the friction. It would just melt the plastic anyway. That's much easier actually. So much better. Oh, Shubas is typing again. What's he going to type this time? God, he does say some funny things. I have no idea what he's talking about. There must be too much kibble in Kentucky tonight. What the hell's that mean? I have no idea. Yeah, so the reason why I'm not using an electric drill is because it goes so frigging fast, it just melts the plastic, and I'm also worried about it going to, and capturing my coils as well. I really don't want to risk using the electric drill. I'm nearly there anyway, so. My wrist is killing me. Okay, 2 more holes to go. Thank God for that. Even doing it at this slow speed, you wouldn't believe how much heat. You would not believe how much heat this generates on the drill. It's bloody hot, and I'm only turning it at hand speed. Right, all I've got to do is look at the mess. Put my bin underneath. Sorry, I've no idea if you can see what I'm doing, but I kind of forget the camera's there. Right, I'll see about coming up and burrs on the inside. Right, all of that because I use round pegs for square holes. The most basic bit of education when you're at school is, can you get a square peg in a round hole? And I forget it. Well, it depends if the square peg is smaller than the round hole. But in my case, no. The round pegs were bigger than the square hole. And I'm just waffling about absolutely nothing right now. while I fiddle about and line up my wires, and because my drill caught them a bit, and yeah. Oh shit, my wire just fell off. Well, it fell off one of the outside concentrics. Well, I'm not worried about that one. I can see the copper tab that I put on there. I could still solder another wire on there if I want to. But yeah, I would say that my coils are starting to look a little bit fatigued. Yeah. So one wire fell off, but yeah, it's a good thing I used copper tape on the bobbins, because I can easily solder wires to that if I want to do. Right, let's see. Let's get this one way round. So this actually goes along that way, so that's that way round. So now I should be able to put this all back together again. Let's see. I haven't got the other brackets on here, so this thing might not fit right. Oh, it might work. I think it's going to work. I think we're going to be alright. It's a bit cramped though, but let's see. Yeah, we're going to be okay, I think. We're doing a test. That's the main thing. I don't know if I'm doing the test right this minute, but right, okay, so that's sitting quite happily there. I have to move my nut back along. This nut back along. I might be able to get the rotors as close as I like to do, because I think they're going to catch on those arms, those bracket arms, because these are lower profile rubber wheels. Because they're lower profile, well, I made them, I 3D printed them, and I stuck heat shrink sleeve in to form a tyre, and because they're lower profile, the first thing that's going to catch the rotors is these freaking back brackets. That's why I want to replace them with these inside brackets, but I can't really do that at the moment. But I'm just going to go with this for now, test it, and then we'll decide later on. Then, well, it's not a question of deciding, it's just a question of doing really. But I am going to remove these brackets and put the new brackets on, which are slotted things. It enables me to position things much more better, and having these inside clamps on, like, actually those should fit that hole, but they don't, because the hole wants to be bigger. So at some point that will be on there, like that, and it will clamp onto the inside, and these outside brackets that would catch on the rotors will no longer be there, because they'll be clamped on the inside instead. But it's just swapping over to that. I can't get these off unless I cut them off with a hacksaw, which I could technically do right now, but I really would like to do a little basic test without messing around too much, because I'm eager to adjust these things, concentric actuator couplers. I want to see how effective they are and everything. Right, so I've got them moved along. Put my bracing brackets back on. Like that. I've got to... Oh, this is the wrong way around. That's that one on. There. Now I've got to bring this lot back in. Oops. My paperweight just went on the floor. I need to put my nuts back on. I use plastic nuts because they're non-magnetic. And I've got to move my rotors back in again. Oh, actually, let me just see a minute. Timing marks, where are they? A1. That middle one's not that good. Oh, there we go. That's lined up with that. Oh, I think it's gonna work as a test. But let me just get the rest of these nuts and put back on. As I say, when I actually take them brackets off, I am going to be fitting the inside concentric on there as well, which means I'll probably have to change the freaking spaces again. Oh, some washers in there. On the bottom ones. Excuse me. I've been eating crisps. They don't normally give me burps. Right, that should be back together now, except I've got to put my belt drive roller, my mouse is dead on me. What's going on with this frigging mouse? I have to keep taking the battery out. I think it's flat. Probably need to get a new battery for it. Oh, the camera is in a really bad place. Sorry. That's with putting everything back together again. It's kind of got a little bit too close. Right, so I've got to put my pulley back on. Oh, I need this back again. The drills have got it. Drills in there right now. Get the drill out. Right. Put this thing on. Why is it not going all the way? That's weird. Right, this should go on. Yeah. Right. I haven't got much drive shaft poking through this end. Come on, out you go. That's good. Well, we're not catching on anything, but the gap is pretty big at the moment. Belt. Where's the dry belt one? There you are. Right. I'm just telling you with my hand. Where's my A1 mark? Are we lined up? Yeah. Good enough. I'll put all this lot back together again. My phone's gonna have to move. Oh, turn it up here. Where's that one there? Right. So, stick that back on there. RPM, revolutions per minute meter. Is that click on? That's that on there. Actually, I could put these ferrites back in these other cars, I think, and they won't get knocked. Put some of them in here. Okay, so now let's see what's next. RPM meter, RPM sensor. That's got to be go back on again. So that's this thing. I'm not sure if it's oh yes, it's magnetic because I've got a magnet on there. Yeah. So the RPM sensor basically picks up a pulse as it rotates around off the little drive pulley and it's driven by a little tiny motor that burns out if you go above 100 milliamps on the drive, because it's a CD spindle motor. And they're not designed for torque, they're designed for revolutions per minute. They're designed for speed, not torque. So you can see how little cogging I've got on this thing. Look at that. I mean, I turn it and there's very little cogging on it. Right. So, my wires, I've got to check these wires now to make sure. That there's nothing shorting out. And I want that wire connecting to that one. I'll try and move the camera over here closer, but the USB lead that it's connected to right now is too short, so I can't really move it. Right, so the tweezers. I'm just worried that these frigging big secondary coil wires are going to snap off next because everything seems to be breaking. Can't hold that torch and do this at the same time. So I'm connecting just the big coils in series, and then I'm going to put my scope back on it and do some more tests on it. Right, I'm not worried about the outside coils because they're going to be in that flux trap and oh shit, oh no, look, another one of my little wires just snapped off. That's off the outside coils though, so I am going to, at some point, I'm just going to have to resolder wires on them. Right, so they are definitely getting fatigued. I mean, I've taken this thing apart, put it back together that many frigging times now. I'm not surprised. Putting clamps on to hold things rock solid. Right, so wires and connect these up to the bottom coils, I think. It's a good thing I've got 8 coils on this thing, and the only wires that have snapped off or dropped off so far are the ones on the little coils on the end, and I'm not really worried about those, thankfully, because those are in the flux trap, and I'm only going to check to see what's going on with those at some point, but I'm not really interested in drawing any power or current off them because that's a bit like bleeding the steam off a steam engine through the whistle, you know, for the whistle. It's an unnecessary section to take energy from, because all I'm doing is bleeding energy from a part of the device before it's gone through the whole process. Right, so those 2 wires are connected. Where's my other 2 wires? That's for the motor. Where's the other one? one, that's that one. I've got 2 more wires to connect up. Oh. Those two, and I need to put the oscilloscope back on as well. And I'm worried about this big wire falling off. I've been pretty gentle with it though. Right. Right, so I want to get this drawers out of the way because I want to put my keyboard back on here because go up there. Right, I'll tell you what I'm going to have to do. I'm going to put these ferrite cores away because they're going to end up on the floor and broken. Yeah, sorry about that. I had to get rid of those things because there's just so much clutter on my table right now. You wouldn't believe it. I can't see the wood for the trees. It's just there's so much stuff lying on the table. I had to get rid of them. I've got spacers. I've got previous beta versions of my designs and everything lying around here. Looks a bit better without all them toys lying on there as well, because they will end up on the floor at some point if I didn't get rid of them. Right, so the question is, well, previously, is the camera on this side? No, it's not. It's over here, so where's my hand? Okay. Okay, I could put my meter over here. Previously I was getting about 2 volts on each coil, that's about 6 volts, 2 in series, so I'm hoping I get a bit more, but obviously the rotors are as close to the actuation, the laminations, they aren't close enough at the moment. I mean, I want to move the rotors closer together, but I've still got the same spaces on between the rotors, so I can't get them any closer, really. I can get them a bit closer, but not much closer. So, I'll shove it to see if there's a difference with these laminations. When I turn the thing on, actually that's only just about visible there. I'll back it out a bit. Right. Oh, what the heck? I'm dropping everything. Got my acetone fringe on the floor. I don't want to be standing on that because it will be squirting about everywhere. And it will destroy everything that's ABS plastic. Right, I'll stick this meter on here. Which one's my scope on? It's on the yellow and green, so hang on a minute. Yellow, green. So I'll put the meter on the white-green one. Then we take measurements from 2 different sections. Right, and put the scope on. Sorry, you won't be able to see it at the moment. Turn things on. Oh, it's catching. Oh, freaking leads. Freaking leads for catching. Voltage looks lower. Actually, let me have a look. Oh shit! That is really low. Why is it so low? Oh, 0.4 something. Well, yeah. Well, that's because I need to get the flipping rotors closer together, that's what it is. Oh, my leads come off, that's why. Flipping wire came off. Right. Oh, that's more like it, 2.61. Right. So I've got 2, I can't get this in the shadow. Right, so we've got 2.61. It is lower than it was with the ferrites. I expect that to be the case because there's a flux trap, basically. Oh, I've got light reflecting on it. Right, 2.63. Actually, that's not bad. Well, we're doing a pretty good speed. Holy smoke! Guess what? I'm actually under load right now. I think. It's going faster now than it was before, which is great because I'm actually under load right now. So the voltage will be lower. Hang on, let me take the load off. What's it now? 2.7, 2.8 now. Yeah, that is definitely better. Now I've taken the load off right now, so there's no load. And the speed, my RPM right now is 662, and there's hardly any difference when it's under load, which is exactly what I wanted. Right, I'm going to put the load, I'm just going to let the speed pick up. That proves that the flux trap is working. Actually, just give me a minute. I want to put the Minicam onto a still image while I put an extension lead on the camera. Give me a sec. Image gallery, just a minute. I need to unplug the camera and move it. Okay, just a minute. This is really good. Okay, I'm not getting as much power voltage out, but that's to be expected because there's a big gap between the rotors and the actuators. But let me put the camera back on. Right, there's the speed without a load. I need to move the meter. You can probably see this oscilloscope in the background. It's there. It's a bit a long way away. Sorry, I can't really move that over here. Right, that's without the load on. Right, now let's put the load on it. I've connected the supercapacitors to the output of the generator now. And look at the RPM. It's hardly dropped at all. It's hardly dropped at all. Yay! My magnetic switches are working. Now, when I use the ferrites, I was not getting that. When I use the ferrites on the output section, right, on this, when I had ferrites in my magnetic trap, they were on this end, and at the bottom as well, right? The ferrites were not acting properly. They were not acting like a flux trap, right? Now I am getting my isolation. I'm getting isolation. The only question is how much output is there? How much power am I putting into the supercapacitors? I need to check that on the DC side. And let me just make sure everything is connected properly though, because I'm not even positive. But I can see it dipping on the oscilloscope. So it must be going in because I saw it dip when I connected the supercapacitors. Let me just double check that. Take it off a minute. Put it back on. Yeah, the top of the waveform is slightly flat. I want to make sure I'm all connected up right. Right, so how my meter's over here. This is the actual voltage output under load right now on one set of coils. Right, it's actually probably not high enough to. It's probably not driving the boost regulator. It's probably not driving it properly at the moment. But I want to check the current on the DC side. So I'm just going to disconnect my meter from this. And connect this on. Right, I don't know if I can see that. Hang on, let's get this in the right place. I have to move this back a bit. I need somebody to put the meter on. Can you see that? Not really. Let's move the camera a bit. Right, let's put this on current. Right, we're going to be DC. So I'm basically going to drain current from the output of the boost regulator. First thing I need to do is disconnect the super capacitors, otherwise I'm going to blow my friggin' meter up or something. I'm going to test how much power is coming out of the boost. So them Chinese boost thingamajiggies. Alright, how much current is on that? Holy shit! 60 milliamps? I am drawing 60 milliamps on the output right now on my speed. It's still above 600. Well, if you saw the previous test, you'll know what I'm talking about. The previous test, I lost 100 RPM when I was drawing 60 milliamps. I lost 100 RPM before. Now I'm only losing, what, 10? Right, let's take the short off again. I've taken the short off, which was through my meter. Let's put the super capacitor. Let's see how much power is going into the super capacitors. Right. Connect that in series. Put that on there. Right, this is how much power is going into the super capacitors. It's only about 10 milliamps right now, actually. 9.3 milliamps. It's not a lot, but I expect that because the voltage at the moment coming out of the coils is only like 2.7 volts. I haven't even got full voltage coming out of there. If I wire these coils in series, I should get a much bigger voltage on there. So let's do that. So what I need to do is I'll find another lead, just a minute. Just a minute. It's a bit awkward getting past the other camera there. Alright, so I'll disconnect these two top leads. Right. Now I need to connect the green one to this top one here. And I need a jumper between that coil. Actually, it has gone up to 680 now. There's no load at all on it right now. Jumper between that coil. I'm trying to get the wire so it doesn't get sucked in by the rotor magnets, because these Chinese leads have got steel in them. And that coil, that wire. Oh, that's better. We've got 15 milliamps going into our supercapacitors now. Let's try. Right, we've got 15 milliamps going into our supercapacitors now. Let's try swapping these around, see if I've got it the best way around. Interestingly, I've got 14 milliamps that way around. So there's a phase. There must be a phase. Yeah, there is a phase difference between the two actually. So this way around seems to be better. But as long as we're getting more power, more current going into the supercapacitors, it's working better. So that's it's probably better in series because we're getting more voltage. But we can actually see that the RPM is hardly dropping. Well, it's not dropping as much as it used to do when I loaded it down. I was losing 100 RPM before. So, I don't know if you're hearing me well enough, but I'll bring the microphone closer now, because... Oh, I've lost my oscilloscope. My oscilloscope was connected to the other two leads. Duh. Oh, let's just bring those wires, let's bring those across. Take this green one off. And this white one off. And put this green one on. And this yellow one on, and we should have these sort of both connected again. Right, that's it. Yeah, I've got my oscilloscope readings back again. Because my oscilloscope was connected to the other lead. This lead. Right, okay. I can see that the waveform is slightly clipped now, it's square. So, and we've got 12.4 milliamps. But these two coils are slightly out of phase, right? There's a slight phase difference, so we're going to lose a little bit of power between the two phases. But that's okay, as long as we're getting more juice going into the boost converter that's charging the supercapacitors, that's still good. Because when I had them in parallel, I was only, what was it, 6 milliamps, 7 milliamps? I'm actually getting twice as much now, so that's better. And RPM is at 652 right now. So ideally what I would really need to do is have more turns on my coils and have a thinner wire on there so that I can get a higher voltage. But as I said, that shouldn't be a problem when I get the rotors closer in, because at the moment I can't get them closer together because I've got spaces between them at the back, and these brackets are in the way. So I could actually gain an extra 10 millimeters bringing them in, but I would start to clash with these brackets. So I'm going to have to remove these brackets, bring my rotors closer together so that they're actually closer to the actuation coupling. Where's it all? Yeah. basically my V configuration, so that the magnet basically passes on the back where the, well, I'll do it on my front so you can see, but the magnet basically is attracted on this end, but on the back, down here, because it comes through the lamination sleeve. So it comes through on the back, and it goes between them, and at that point it's easy to release. It doesn't cog very much, that's the whole point. So this reduces cogging. So it sucks it in at the front, but as you're going through, it's a very, very little cogging effect, and then it comes out the back, quite easily actually. So that's what's in there, but they're adjustable. I haven't even adjusted them yet. The new ones are adjustable, and I've not even attempted to adjust them yet. But actually adjusting them while it's running is probably a little bit hazardous to my health, because my finger's going to get caught in the rotors. So what I'm going to have to do, what I need to do is get some ABS plastic. I need to stick some little plastic arms on them that stick out, and I can basically, like a lever. So what I really want is a lever that comes out onto them concentric, which I can adjust from the outside without getting my fingers in the works, and that's probably the next step. So what I'll probably do is I'll 3D print a little ring, an eyelet. I'll 3D print an eyelet thing that goes around them with a long arm, and then I can just slip it over, acetone it on when I've got the lever just where I want it, sticking out the front, and then I'll be able to adjust the lever from the front without getting my fingers in the way. But I can't get to them right now because they're right down there between the rotor and the thing. If I stick my finger in there, it's going to get I'm going to lose my finger. Yeah. But I did line them up pretty much where they need to be. So we've got 10 milliamps going into the supercapacitors at the moment, and that's over here. And them LEDs should come on at some point. I'll stick them here where you can see them on camera, but there's nothing lit up yet. But them LEDs should all start to come on as it charges up. But yeah, I'm really chuffed with the result actually, because I mean, I am getting more RPM, I'm getting more current to my boost converter, and I'm not seeing much difference when I take the load off. Let's take this off current. If I take this off current, which is supplying the supercapacitors, we'll see what the difference is. Right, it's off current now. That's reading kilohertz, or 140 hertz right now. So hardly any difference on the RPM at all. I mean, it's not whizzing, accelerating really fast or anything, it's just gaining a few RPM, which is negligible. I mean, it's stopped now, look, 666. Yeah, cross my heart, yeah, I hope to die, I won't do anything wrong, blah blah blah. Yeah, I better go back to current. Right, we're back to current. It's dropping at what, 5, 6 RPM? Not much. We're actually drawing 10 milliamps right now, so it's not a lot, I know, it's not a lot, but it's still better than what it was before, because when I was with the ferrite cores in there, when I was drawing like 15, 20 milliamps, I was losing a good 90 RPM. I was losing nearly 100 RPM before. And now I'm losing probably 4 or 5. And the waveform is pretty sinusoidal, except when it's under load. It looks clipped. It's obviously clipped when it's under load, but I still haven't got enough voltage. My peak to peak voltage is 8.6 volts, which really isn't not that much, really. I think before I was actually getting a bit more voltage, but my pulse width is 15 milliseconds. I'm looking at the oscilloscope. Cyclic RMS is 3.2 volts. I mean, I'm hardly getting any voltage at the moment because the rotors need to be brought in a bit closer. But the frequency is what? It says 32 hertz. It's jumping around between 32 and 64. It's obviously a harmonic, the 64. So it's around 32 hertz according to that. The peak, I've already said peak to peak, haven't I? 8.6 volt peak to peak. Yeah. So yeah, I ain't got the scope set up to measure anything else right now. So. How's my torch? I want to check this. See if they're lined up. They look pretty well lined up. Actually, those bottom ones look like they need to be a bit higher up. I don't know why. No, actually, that's about right. It's pretty good. I'm trying to see if I've got everything lined up properly. It looks like it needs to be moved back a bit as well, because that's why I was printing new brackets. It probably needs to be a bit further back. Oh yeah, look, when I push this back a bit, the current goes up. What? Oh, blocking the view, stupid me. Alright, look at the current on the meter. If I push this back a bit, it goes up. So yeah, there's still alignment issues to deal with. And when I get the new brackets on there, I'll be able to move it and tweak it and get the maximum current output, and then I'll be able to super glue the brackets into a certain position. I'll still have to remove them by unhooking them like I do, but when they're super glued in place, every time I put it together they'll be exactly lined up, you see. But let's see about this bottom one. Oh yeah, it goes up when I bring it in a bit further. Well, I'm not seeing any LEDs coming on the supercapacitor. I think the voltage is probably too low right now. It's probably going to take a long time to charge them up at 7.8 milliamps, because it's actually dropped, and that's because the voltage is coming up slowly, so the current's dropping off. I mean, as the voltage on the supercapacitor rises, the current on the input will drop, which is to be expected. So now, another thing I want to find out is the voltage between the magnetic track. Now, I'll have to put this back on AC. I'll just bypass this a minute, put this directly on, so we're not measuring current anymore. Right, let's put this directly on the supercapacitor. Now, I want to check the AC current on the magnetic track itself, right? Now, when you load that down with a current, it will slow down a hell of a lot, because it's right across that track, this area. Now, let's see what AC we get across this track. It's probably going to be a lot there. Oh, it's actually not as much as I thought. What? We've got 0.84 volts across the magnetic track. Wow! I was expecting that to be more. Well, it's obviously working really well, because is this the one with the wire fell off? I don't know. I think that's the one with the wire fell off. I can check the one at the bottom down here. Oh my god, there's about 1 volt across the magnetic track, the flux track. So that's, yeah, it's definitely working, but I was expecting to see a bigger voltage deviation across there, especially when it's under load. But it's probably not surprising, because the actual magnetic track itself has only got some steel laminations going through. There's a very small amount of coupling, and it's mostly switching flux magnets. It's pulling them together or separating them, so it's not, and it will cancel it. Oh, of course, it will cancel itself out, won't it? Yeah, that's right. So what happens is the flux. So north and south is being pulled together first, right, on this side. So say north is on the left, south is on the right. They're being pulled together, then they're being flipped apart. And then the other side is, on the other half cycle, north is on the right and south is on the left, and they're pulled together. So what we're seeing is a cancellation that's going on. So we're not seeing much of a voltage across those tracks, but there's a hell of a lot of flux fucking around. But it's not generating any power, and that's fine, because I did say earlier that them coils were really there for just measuring, really, just to see what's going on. And at some point I could just take those end coils out completely, just do away with them. I've left them in for now because I wanted to be able to take some readings from there to see what's going on inside the track. And yeah, I was actually thinking that there might be more of a voltage across there, but there's obviously not. But that doesn't matter. What's important is the voltage that we get across the main coils in the centre. You know, that's the important area for the output section, really. And there need to be more turns and thinner wire, really, to get the more voltage out. And the rotors need to be brought together more, so we get even more voltage coming out. So more voltage and current, that is. So there's a few tweaks and jiggling to do, but I tell you, it works completely different to having the ferrites on the end. So when I had the two ferrites on the end, that trap wasn't working very well, and when I put a load on this middle coils, we were losing about 100 RPMs in speed. But now I'm only losing a small amount, and initially when I shorted these out, I remember when they were all ferrites, when I shorted the center coils out, I was seeing a current consumption of about 100 milliamps, so I was seeing more current being drawn. But now I'm seeing around 68 milliamps. Let's put the meter back on. AC. So when I short these, let's actually we're in series right now, aren't we? So I want to short. Let's just short that one. That one. Oh, my meter's still turned off. I'm on AC, I'm on current. Oh, that's about the same, 83 milliamps, that's still good. So, when I short it out, AC, I'm actually drawing about 80 milliamps on the AC. Right, and we have lost some speed, but not 100 RPM. Yeah. I didn't have it on long anyway, but that's with them both in series though. Last time I think I was in parallel when I was doing a test, but oh well. Anyway, I still think it's better than it was before. What I really need to do is time how long it takes. I did a live stream earlier when I was charging up the supercapacitors, and I need to see the LEDs come on, but I think it's probably going to take about an hour or so, because them supercapacitors take a long time to charge up at 16 or even 5 milliamps, whatever. So yeah, I'm probably going to end the stream because I don't know how long I've been waffling and going on and putting this thing together, whatever, but I think we need to do another video, another stream at some point with when I finished all these adjustments and everything. So I think that's pretty much that for now. Let's see, where are we? I need a drink of coffee right now. Yeah, and you see there's a phase problem, there's a phase difference as well, so I'm losing power because it's in series, and between the two phases, one's going to clip off, and then when it clips on, it's just coming on and the other one's clipping off, so there is a phase shift slightly, and they're not perfectly synced, the two coils, you know. So I'm really only drawing power out of it at about 60% the cycle, the effective cycle. So I'm actually losing some of my power, but I am gaining voltage and I am gaining some current, but I'm still not taking the full advantage of the phase because the phase is slightly out of sync. So I wasn't really planning on having them in series anyway, really, but it's an interesting thing to have though, because it enables you to do some testing with a phase shift that you might not otherwise have, because it's very difficult to create a phase shift electronically, really. But because it's mechanical, it's too easy to do it, you know. So I think what I'll need to do is take that middle spacer out, the silver one that's in the middle, which is basically about 8mm. So I'll gain an extra 4mm closer on each side to begin with, but I want to get them brackets changed anyway. So. I've also got to fit a central concentric as well, which will also give me more isolation. So there's not much to see on the oscilloscope right now. It's just basically a sinusoidal waveform that's slightly clipped because of the load factor, because it's loaded down. So nothing spectacularly unusual about that at all. Let me see. I'll take a picture on my phone because I can't move the camera easily. So. If I go across the room, take a picture, that's the easiest way there. Let's see. Right. Don't know if that's on the camera. Oh, it'll be going off now. Ah, stupid thing. Hang on. Photos. There we go. Oh my god, I've got motion blur. Oh my god, what the hell? Oh god, we have to do that again. I've got terrible motion blur on there. Oh, it's terrible. Alright, don't know what happened there. Yeah, basically. Oh, it's gone again. It didn't stay on there long enough. Right. Anyway, that's the photo I just took of the scope. That's the waveform. So it's just easier than moving the camera, and I can't move the oscilloscope, it's too bulky, and the wires are just, my power lead's not long enough. Anyway, that's it for now. I'm going to turn the stream off and I'm going to leave this running, and I'm going to wait and see if them LEDs come on the supercapacitors. Actually, can't see a dicky bird right now. The leakage is probably greater what's going in actually, I don't know. That's that for now.